All right, so coming into 6.2 now, we're taking a little bit of a different step. So now we're talking about factoring trinomials. And 6.2, 6.3, and 6.4 all are very, very closely linked, actually 6.5 as well. So we kind of break them into different sections not to overwhelm ourselves. So we only have one objective here, and that's to factor trinomials of the form x squared plus bx plus c. All right, so specifically this form where the coefficient on the x squared term is 1. So that's what we're doing. So our first box here, what we do to factor this is we find two numbers whose product is equal to c and whose sum is b. So what that means is this factors to x plus m times x plus n, where m times n equals c and m plus n equals b. So there's a couple ways that we do this. You may have heard of something called like the magic T or magic cross. That's kind of the main thing that gets done. It's how I learned it once upon a time. So we're just going to walk through 6 examples here to get used to it. And again, this should seem familiar. You maybe have seen this in another class, but if not, that's okay. That's why we're doing it. That's why we break it into its own section. So number 1 here, this is what I mean by the magic T or magic cross. So I look for something that multiplies to 16 and adds up to 10. And typically what we do is we just list the factors over here of 16. So we have 1 and 16, we have 2 and 8, we have 4 and 4. And then I look at, do they add up to 10? Well, 1 and 16 don't, and 4 and 4 don't, but 2 and 8 do. So those are my numbers. 2 plus 8 is 10, 2 times 8 is 16. So this factors to x plus 2 times x plus 8. And we're done. That's what's really nice about this form. When you have a 1 instead of a number on the x squared, you can factor really easy. So if we go to number 2 here, again, set up the little magic cross, 35 and negative 12. So we're multiplying to 35 and adding to negative 12. Now when you're adding up to a negative, you want to be thinking, okay, if I'm going to add up to a negative, at least one of my terms needs to be negative. So keep that in the back of your mind. And then we'll list out the factors of 35. We have 1 and 35, and we have 5 and 7. So if one of these terms has to be negative, at least one, you can kind of play around, but also when you are multiplying to make a positive, you only have so many options because only positive times positive makes a positive, only negative times negative makes a positive. So if I have to have a positive positive or a negative negative, and I have to add to a negative, that means both of them need to be negative to make this work. And then obviously negative 1 plus negative 35 does not equal negative 12, but negative 5 plus negative 7 does. So those are our numbers. That's our m and n. So then this factors immediately to x minus 5 times x minus 7. Okay, coming down here to number 5. This doesn't have the right format. That's why we do GCDs first. So I notice here I can factor out some numbers. I want to at least be able to factor out a 5 and an x, and we can see that all of these will do that. So this is 5x times x squared minus 6x minus 7. Okay, now I'm looking for things that multiply to make negative 7 and add to negative 6. Well, the factors of 7 is only 1 and 7, so now I just have to figure out how to make my negatives work. If I want two numbers to be multiplied to make a negative, one of them needs to be negative. And since I'm adding up to a negative 6, I know that the bigger one needs to be the negative. And so this means our final answer, the 5x sticks around. And then this trinomial, x squared minus 6x minus 7, becomes x plus 1 times x minus 7. And that's the final answer. So we always want to be looking for GCDs to factor out first. So coming up to number 4, we can factor a 2 out from 2, 38, and 80, and this gives us x squared minus 19x plus 40. So then we're going to set up our cross, and we're multiplying to 40 and adding to negative 19. So we list out our factors: 1 and 40, 2 and 20, 4 and 10, 5 and 8. And we know that they either both need to be positive or both need to be negative because we're in the same situation that we were down here in number 2. So if they're both positive, there's no way to add them up to negative. So I know they both need to be negative. And then we just look. Negative 5 plus negative 8, negative 13, that doesn't work. Negative 4 plus negative 10, negative 14, that doesn't work. Negative 2 plus negative 20, negative 22, that doesn't work. Negative 1 plus negative 40, negative 41, that doesn't work. So when this happens, this means that 2 times x squared minus 19x plus 40 is our final answer. This is fully factored. And we need to be able to recognize when it's fully factored and not try and force something to work that doesn't. So what this means, this little magic cross that we've done here, is that x squared minus 19x plus 40 is what we call prime. Meaning that it can't be factored, it's already fully factored. Now our final answer needs the 2 because we had to factor the 2. And our instructions were to factor the following, so we know that that does need to happen. All right, so this is what it's called. It's called prime when you can't factor it any further, just like a prime number. Prime number can't be factored, except for 1 times itself. Okay, so moving on to number 5. Again, we have this 3 here, so we want to factor out a 3. We have a 6 and a 6, so we know it's going to work. So we have y squared plus 2y plus 2. We need to multiply to make 2 and add to make 2. Well, that only works one way. That doesn't work the same way that I'm thinking. The only factors of 2 are 2 and 1. And they certainly don't add up to 2. So once again, our final answer is 3 times y squared plus 2y plus 2. That is fully factored, just like number 4 was. Okay, so if we come down to number 6, I need to factor out, I have an x, I'm going to factor out a 6 from 6, 24, and 30. So 6x, we have x squared left, plus 4x, minus 5. So we're doing things that multiply to negative 5 and add up to 4. Well, negative 5 only has so many factors. And since we're multiplying up to a negative, only one number can be negative. And since we have to add up to a positive, that means that the small number needs to be negative. So we have our negative 1 and 5. So the 6x sticks around. X squared plus 4x minus 5 becomes x minus 1 times x plus 5. All right, so as you work more problems in the homework, you'll start to recognize, and you'll start to recognize what terms need to go here. So like, for example, number 4, you'll see, well, there's nothing that's going to multiply to 40 and add up to negative 19. If you forget, just list all your factor pairs and just eliminate them one at a time, right? Add them up. If you don't get the right number, you know it's not right. If you have negatives, think about what both numbers are. If you're adding to a negative and multiplying to a positive, they both need to be negative because you can't multiply to a positive if one is negative and one is positive. If you're multiplying to a negative, then you know one has to be negative and not both. So just little tricks that you'll start to pick up on as you do more problems. So keep an eye out on those as you work through the homework. And next up, we'll be factoring more trinomials, a little bit harder trinomials, where we don't just have a nice 1 as our coefficient on the quadratic.